And I'm live. That is pretty cool. Today is 24th of January 2026, Saturday, and with that, let's just not start solving questions, but we will review questions from yesterday's contest. Yesterday was a Division 2 contest on code forces. Mm, this one, and I was able to do 3 questions. And yes, first of all, we have to go through all of these 3 questions, and maybe we will see how we can do these later questions also, C2, D1, and D2. So for question number one, the first of all, I have to say the language was very bad. Mm, Yes, the language was very vague and not very clear. Yeah, the language was unclear for this. So we had here Peter drew a table of size h into L filled with zeros. We will number its rows from 1 to h from top to bottom and columns from 1 to L from left to right. Ned came up with an array of numbers a1 to an and wanted to modify the table. Ned can choose 2k, which is smaller than or equal to n numbers from this array, and split them into k pairs. After that, each resulting pair xy, he takes the cell located at x row and column y and adds 1 to the number in that cell. If such a cell does not exist, then this pair does not nothing to the table. Peter supported and he wanted to maximize the total sum of the grid. So, yep, what we have is a grid, normal, cool looking grid with sloppiness. Okay, and yes, those are very straight lines, not these one. We have a grid, and this grid has a height h and a length, which is this, and each column can be represented by h comma l, and we have been given an array a which has a bunch of numbers, and what we can do is from this array we can choose numbers in any way we want and make pairs out of them. Let's say we have, let's say, numbers a, b, c, d. Then we can make a pair, let's say b, c, and we can make a pair a, d. And if this pair represents a cell in our matrix, in our this grid, then we will initially all the values in this grid are 0. And if this pair represents a cell in this grid, then we will add 1 to its value, and we will keep doing this. And our main goal is to maximize the sum after adding ones to different cells, which just means that we need to find the maximum number of pairs from this array A which represent a cell in this. And if we choose a pair from A, which is like greater than H or greater than L, that is, if it is representing a cell, then that cell maybe is outside the grid, then we cannot do anything. So from A, we have H and L. From A, let's say Cn or MH, let's say, represents all of the numbers which are equal to or smaller than H. And we are saying that H is smaller than L, smaller than equal to L. So H is the smaller one and L is the bigger one. And ML is the number of numbers in A which are smaller than or equal to L. And yep. So in A, if we put all the numbers in ascending order, like let's say in vertically, and let's say H is at some point here and L is at some point here, since we are forcing H to be bigger than L. If L is bigger than H, then that is good. But if we see that H is greater than L, then we can just swap their values and it works. So let's say mh is the number of numbers which are smaller than h in A, and ml is the number count of numbers which are smaller than L in A. So these numbers, these numbers which are greater than h but smaller than or equal to L, these numbers can only be chosen as a coordinate for this L part, and for each of the choice in this range we can choose any number in this range and it works. So we can make pairs like this, choosing numbers from here or here. So let's say, yeah, we already know that this is mh, and we want to know how many numbers we can choose from this range, because these can only be chosen for the L coordinate. So the maximum number of numbers we can choose from this would be minimum of ml minus mh, ml minus mh, ml minus mh, comma mh. There can be three scenarios. Either this range, wait, yes, either this range here is greater than this range, and if that is the case, then we can only choose out of this mh numbers, because yeah, we don't have enough numbers here to go with all the numbers here. Or we have that this range is smaller than this range, in which case we will only be able to choose ml minus mh numbers, only numbers from this range, and we will have some leftover numbers from here. And if both of them are equal, then yeah, we if both of them are equal, then these two numbers are equal and minimum would be equal to that. So that would be our initial response, would be this minimum of these two values, either this range or this range. And after that we have to see at how many numbers are left in this range which have not been chosen, which is equal to mh, this total range, minus the numbers which have been chosen, which is just res. This is how many numbers are left here, and these numbers in this range can be chosen as coordinates for L or H, does not matter. So, and since we need pairs out of this range, so we will divide this by 2, and our final answer would be this thing plus this number mh minus res divided by 2, which is actually correct. Lazy update synchronize. And the only problem in this problem was the language. Language was very bad. Language for this problem was unclear. Wait, shit, where is my solution? Mm, Competitive programming. And yep, yep. Here's the solution. We take in n, h, and l. When we take in the vectors a, then we check if h is greater than l, which we do not want. We always want h to be smaller than l, therefore we swap. And then res and okay, is smaller than h and is smaller than l. And then we like calculate sh smaller than h and is smaller than l, and then res becomes equal to minimum of smaller than h or smaller than sl minus sh, and just the same formula from here, and this works. And now on to problem number 2, be the curse of the frog. And in this we have on an infinite number line at point 0 sits a frog. After many years of meditation, the frog has mastered any unique types of magical jumps. And in this question problem also, there was the same problem of this statement being unclear. This was unclear. The ith type of jump allows it to jump forward by no more than AI units. Okay. In other words, if it was at integer k, after jumping, it can land at any integer point from k to k plus AI, right? If we are at point k and there are n types of unique jumps, and using the ith jump, we can move forward AI times. So if we are at k, we can go to k plus AI or any range between in this range. But there is a twist, and that is after or at each bith jump, for the ith jump, we are set back by CI units. So for example, let's say we only have one type of jump, and using that, AI is this, A1 is this 5. We will move forward by 5 amounts. And B1, let's say, is 3, and C1 is, let's say, 4. So this means when we choose this jump for the first time, if we initially are at 0, when we choose this jump for the first time, we will go from 0 to 5. That is cool. Then when we choose this jump for the second time, we are at 5. We will go forward by 5 AI amount, A1 amount, and we will go to 10. Then when we choose this jump for the third time, which is B1, third time, then before jumping forward by 5 units, we will go back by 4 units, and then we will jump forward by 5 units, which means we were at 10, we have to go back 4 units, setback, minus 4, we land at 6, and then we move forward by 5, which would be 11. So yes, and then for the fourth jump, we will go from 11 to 16, and then for the fifth jump, we will go from 16 to 21, and then again for the sixth jump, which is a multiple of 3 bi here, we will go back by 4. So 21 minus 4 gives 17, and then we will jump forward by 5, and we will land at 22. So yes, that is it. And yeah, that is the problem. And in this problem, our goal is to reach a certain point x from the starting point. And this one is simple. We can look at jumps in two ways. We there are two types of ways in which we can jump. One is we jump forward using this type of jump, using ith type of jump. We jump forward using no rollback, and that would be AI. The maximum units we can move forward without rollback would be AI mine into bi minus 1, because on the bith jump we have to do a rollback. So for every ith jump, this is the maximum amount we can move forward without a rollback. But if we are considering a rollback, IR rollback, we will move forward by this much amount. We will do I jumps, BI jumps, but we will go back by CI amount. So this would be the distance covered when we do a rollback. So for all of the jumps, we need to minimize the number of rollbacks. So what we will do is, for each jumps, for all the n jumps, we will take this amount, this number, which is the maximum distance forward without a rollback, and we will keep this in a sum. And yeah, this is the maximum, this sum would be the maximum distance we can move forward without a rollback, and we will add this for each jump, and yeah, we will have a sum. Then we will compare our sum with x, which is the target. And if sum is greater than or equal to x, then we can move to x without a rollback. So our answer in that case would be rest would be 0. But if this is not the case, if sum is smaller than x, then we have to use some of the rollback jumps. And the best rollback jump would be the jump which with the highest value here, with the highest rollback value, the ith jump which has maximum, which has this thing as the maximum. So like, yes, ai into bi minus ci, whose maximum is this. And we will look at the difference would be, since we have already moved forward by some amount, so difference would be x target minus sum, that is the difference, and the number of rollbacks required would be this divided by the maximum rollback, let's say mr maximum rollback, and we need its upper limit like this. So yep, and that would be our answer for this one. Babos, okay, we will go and buy your harmonica. It was funny to me to see how you get so many views when you do competitive programming stream. Yes, as compared to when you actually learn something useful, and then later on cry about how, okay, like this is also useful. This is also very fun. Yesterday, while giving the contest, I was like so pumped up. I was doing push-ups before the contest, getting ready for the contest. Yeah, it is very fun. It is very fun until it is not very fun and until it is depressing. But when it is fun, it is very fun giving contests. And yes, it took me 24 minutes for this problem, and it was cool. This one was cool. Here is the link if you want to check it out. Taught something practical, and yet India's ranking is shit in CP. Yes, because I would say quite a lot of people do cheating, and a different kind of mindset is required for this, for CP to get very good at CP, which I do not have, but hopefully I will get better with time. Okay, and for this problem number B, the curse of the frog. Let's write this one from scratch. Yeah, n and x the target, and then ai, bi, and ci values. N and x, c in n, and c in x, and then we will take in three values a, b, and c n times for n I equals 0, I smaller than n, I plus plus, and c in a, b, and c. And we will keep track of our sum variable, which is the maximum distance we can move forward without a rollback. And it would be really cool, not just cool, it would be necessary to substitute all of these ints with a long. Yep, c in this and long sum initially, which is equal to 0, and the maximum distance we can move forward with this ith jump without a rollback would be a into b minus 1. And we will also keep track of the maximum rollback distance. So mxr, maximum rollback, which we will say initially is minus infinity. How do we say minus infinity? Well, 0 is not good, but we can literally say 0, yes, because 0 rollback is not very good. And mxr equals maximum of mxr comma maximum rollback would be a into b minus c. Yeah, and we will only do this if sum is smaller than x, because we are multiplying two long integers together and we are adding it to sum. We do not want to do this a lot. So here if sum is, and also interest equals 0, or long rest equals 0, and if sum is still smaller than the target, then we have to see the maximum rollback. Yep. If maximum rollback is greater than 0, then we do have a chance. Otherwise, rest would be -1, like not possible to reach the correct answer. Otherwise, answer is possible, and it would be difference. Difference is x minus sum, and we have to do difference divided by maximum rollback, and we have to take this number's upper limit, for which we can add to this mxr -1. And here see out rest, and we will get the correct answer. Okay. And we can just submit just in case, even though it did work yesterday, just overclocking their servers. Yo. Fun is different from practical knowledge. Like, yeah, it does teach you about data structures. I don't like data structures and think about time complexity and such, but in the wild, things don't always work like that. Yes, and they don't always. Like hash maps has lookup time complexity of this, but the constant factor is too high in normal hash maps. So in this, okay, it is running. In this, using there is linear and there is shit. What is the in type? What is the type of containers in CPP? There is linear and there is okay, sequence associative. Yes. So yes, associative containers which store things in form of like red black trees and things like that, they are faster in practice. But in certain in real life cases, arrays are much faster and better, even though it has a lookup. Wait, arrays do not have a lookup. Arrays do have a lookup time of this. It no, I have not seen arrays having better lookup time. We can use associative containers like this, which use log n time, which is cool. Log n time is cool. Yep. And due to CPU's cache locality and these things, people usually notice this when actually writing something instead of just applying algorithms. Because in isolated cases, the theory of algorithm is perfect, but in theory with many moving parts, there is a question mark. And hello, yeah, but this is teaching you quite a lot, teaching you how to think and telling you how to write code, which is cool. And for this problem, this one, uh, I spent way too much time than I should have. There was a simple realization that must have been there to solve this question problem. Given a natural number n, find a permutation p of length n such that for each integer I from 0 to n minus 1, from second to the second last, there exists a j which is equal to or greater than I till the last element, such that pi, the current number in this permutation and the current position, is equal to the XOR of the index of the current number and a number at the jth position, which means if we have, for example, n equals 3, then I think it works as 1, 3, 2. We can have this permutation, and permutation for a length n is just an array of length n where we have all the numbers from 1 to n appearing once in any order. That is a permutation. And they are saying for we need to find a permutation of a certain length which has one property, and that property is, if we start from the second element, let's say this is the second element here, or let's say for n equals 4. For n equals 4, we'll have 4, 1, 2, 3. This array works. Here, when we begin from I goes from second element, which is 2, till the second last element, which is 3. And we are saying that for all of these indexes of I, we need to have, mm, let's say this is A I should be equal to A J XOR with I. So for this place, right here, I is 2, AI is 3. So we want 3 equals I which is 2, XOR with some number should give us 3. And this AJ numbers either is this number, or this number towards the right, or the same number itself. So here if we see, if we take XOR of 1 with 2, we do get 3, because 0 1 which is 1 and 1 0 which is 2, this XOR gives us 1 1 1 1 which is 3. So this does check out for I equals 2, and for I equals 3 we have AI is 2, AI, this, the number at this place is 2, and the index is 3, its XOR with some number, either this or this, should give us, it should satisfy this condition. And if you put 1 here, then we have 0 1. XOR 3, 3 is 1 1, and this gives us 1 0 1 0, which is 2. So this also checks out. And yes, for this problem, I just did some randomization. I was looking at how to put numbers together, and I ended up trying a few different ways, and I found out that if we always put 1 here at this position, and we take its XOR with all the indexes before it, we can put that number at that index, which means if we have, let's say, n equals 6, right? Yep. For small value of n, cache is much better than hash function. Yes, I would say. Then, yeah, hash functions are slow, and it does not matter on how what the size of the array is. Hash functions will always take quite a bit of time. Hello, new. Actually, let us see the grind. Okay, like I do not look at this as a grind, but yes, let's solve some problems. For example, let's say n equals 6. Then we need to fill up 6 places. 1, 2, 3, 4, 5, 6. Indexes are this 2, 1, and our I, the places for which we have to check our condition, are from this till this second last. And I'm saying that if we put 1 here always, then at every other place like this and this, we can just take XOR of this number with 1 and put it here. And let's do this. So for 5 is 101, XOR 0 0 1, which is 1. This gives us 1 0 0, which is 4. So we will put 4 here. And for 4 is 1 0 0, XOR 0 0 1. This gives us 5 0 1 0. So we put 5 here, and XOR of 3 and 1 is 2. So we get 2, 2. We put 2 here, and XOR of 2 1 0 with 1, which is 0 1, is 1 1, which is 3. And for this one, we will not take XOR, we will just put whatever the remaining number is here we have used 1, 2, 3, 4, 5, and 6 is the remaining one, so we will put 6 here. And this checks out because yes, this checks out. This array follows the required property, and no matter how big n is, this will always work. And now as to why this works, because since we are taking XOR with 1 always, the only concern might be, there are two concerns. First of all, the numbers that we get after taking XOR of 1 with some number x, let's say it turns out to be y, and let's say XOR of some other number, let's say x dash, it also turns out to be y. This is our first concern, which is a repetition. And our second concern is that this number that we get after taking XOR, this y is outside our range. It is greater than n. So we won't be able to use y in this case. So for repetition, we can be assured that we will not get same numbers, because if we are saying XOR of some number with 1 is y, then we will never get XOR of 1 with some other number also equal to y, unless x and x dash are equal to each other, which we can test by equating these two, putting these two equations together. 1 XOR x equals 1 XOR x dash, and we can take XOR on both sides by 1. So 1 XOR 1 XOR x equals 1 XOR 1 XOR x dash, and XOR of the same number with itself is 0. So 0 XOR x equals 0 XOR x dash, and XOR of any number with 0 is that number itself. So x equals s x dash. Therefore, we do not have to worry about repetition. Repetition would only occur if x is equal to x dash, and since we are taking XOR with the indexes, and indexes are always changing, they go from the second last till 2, so they are not repeating, therefore we will not get repeated XORs. So our first concern has gone. And now about the second concern, that the number that we get might not be in our range. The number y that we get might be greater than n, which is outside our range, or y might be smaller than 1. And y cannot be negative because XOR does not give us negative number. It does not make sense to give us negative number. So y can be maybe 0. But y equals to 0 would only be, since we are taking XOR with 1, y would only be 0 if we take XOR of 1 with 1. No other number will give us y equals 0. And we are saying here that we are going till 2, we are not going till 1, so we are never taking XOR with 1, so y would never be 1, y would therefore never be 1, y could be greater than n. And now about this one is cool, since for our array index 0, index 2, dash dash dash, uh, n minus 1, and last index is 10, we have put 1 here at the last index. And for large values, an array would be slower because CPU cannot load the whole array into cache, since the cache is smaller, so it needs to be read from memory. So hashing do gets speed for large n. Okay, I was referring to the fact that hash functions have a constant speed, and that constant speed is quite high. But for cache, using change in the size of input does change the speed of how fast the operation is going on. So yeah, for small n, it is cool to use hash, to use array or associative function. Okay, so we are saying here for our final response array, at the last index we are putting 1 here, and our greatest index is going to be n minus 1. We will take its one XOR with 1, and we are taking XOR with 1, and 1 in binary is just 1, nothing special, which means all the zeros before this are zeros. All at all the places before this we have zeros, and only this last point is 1. So if we are taking its XOR with some number, let's say x, if x has whatever zeros or ones at all the points beyond this, like this is ones place, this is twos place, this is fours place, eights place, only ones place is the only thing which is affected in this number x. Ones place is the only thing. And since we are worried about that y, the final XOR of x, might become bigger and might become big, and we are saying only this ones bit is the bit that is changing. So big, x becoming big would mean x plus 1 if x is even, which means if x is last, or if x is bit in this, like 0 in first place is 0. And I'm not doing a very good job. Okay, for let's say for a number like 5, which is 101, and for a number like 6, which is 110 in binary, we are taking their XOR with 1, and this bit is the only bit which is going to be affected in the final answer. And if there are only two possibilities, this bit might be 1 or this bit might be 0. If this bit is 1, then this bit after taking the XOR will become 0, and if this bit is 0, it will become 1 after taking XOR. So 1 1 1, this is 7, and this is 4. If the last bit is 1, it will become 0, which is decreasing. And since we are only taking XOR with indexes, then we are getting a smaller number than the index here, and this index is at maximum n minus 1, and we are getting a number which is smaller than n minus 1, which is within our range, so this works. But here we are getting a number which is greater than our current number, and the difference can be at maximum 1, and this number at maximum can be n minus 1 because that is the highest index that we begin with, and the maximum difference between the final number that we get after XOR and our initial number with which we began taking the XOR is 1. So yes, y minus x, the maximum difference is 1, and the maximum number with which we can start with is n minus 1. Therefore, the maximum final value of y which we can get is n minus 1, the maximum number, plus the maximum difference, which is 1. Y at maximum will be n, which is within our range. Therefore, y cannot be greater than n because the maximum y that we can get is n. Therefore, we can just put 1 at the last index for our response array and keep taking its XOR, and it will check out. And I hope that makes sense. Let's write code for this. Boilerplate. Okay, what do we have? We just have n, nothing is special. N, taken n, and we are saying vector end response n, yeah, response of size n, and res n minus 1, the last index, the last place is 0. And then we will say I will begin from n minus 1. While I is greater than 0, we will not go to the last, into the first index, and I minus minus res I would be equal to 1 XOR with the index, and this I index is 1 is 0 based. We want it to be 1 based, so we will just add I plus 1 here, and this would be our answer. And for res 0, we need to figure out which number was not used in this range, for which we can keep a bit set here, const int size equals 2e of 1e6, and we can have a bit set of size, we'll call it used, and everything would be false initially. And yes, before this we have to go through the bit set int I equals 0, I smaller than equal to n, I plus plus, used I equals false, nothing is used. And whenever we do use some number, we will say used 1 XOR I plus 1 equals true. And then we have to find out the number which was not used, and we will also say that 1 was used, so used 1 was equals to true. And here we have to find out the number which was not used. So for int I equals 1, I is smaller than I is smaller than equal to n, I plus plus, if not used I, and then res 0 equals I, and then we will print the answer I smaller than n, I 0, C out, res I space new line I equals n minus 1. That should work. This will say a wrong answer, I think. Yes, this does say a wrong answer. Why do we have 0 here? We have 0 here. This should not be this. N minus, okay, shit. N minus 2. This should be n minus 2. My bad, my bad. Yeah, cool. There you go. This should be n minus 2 because I is 0 indexed, and the last index therefore is n minus 1, and therefore the second last index would be n minus 2. So this works. Now this is different from what the answer is given us here, but this is also correct. Select this, copy, submit, and this just works. Hopefully it does. Yep, accepted. And now for the interesting part, the hard version of this same problem. I was not able to do this during the contest, and the only difference between this hard version and the smaller version is that we do have to go to the first index. So before, we had a property which must satisfy all the numbers starting from the second till the second last. But now the same property must be satisfied for all the numbers from the first number till the second last number. That is the only change here now. And that is difficult to figure out. There were, yes, out of 8,800 people who did the easy version, only 3,000 were able to do the hard version. So yes, this is a bit difficult. And shit, there is a difference. Wait, shit. This works. Okay. And if there is no suitable way to arrange them in this way, then we can also say -1. And the interesting thing is that we see -1 here for a power of 2. Maybe there is no way to arrange a power of 2 in such a way. Let's see. Let's say for n can be at minimum 3, and when n is 3, our domain is 1, 2, 3, and we have 3 places: index 1, index 2, index 3, and we have to put them here. The answer that is given to us is, I think, 3 here and 2 here and 1 here. And if we do check, XOR of this and this must be 1, which it is 1, and XOR of this and some other number, which is this, should be 2, which is 2. XOR of 1 and 3 is 2. And they are saying if we add a fourth place, then there is no way we can make this work out. Okay, maybe that is an indication that all the powers of 2, if n is exact power of 2, like 4, 8, 16, then there is no solution, maybe. Let's look for n equals 5. Guessing for n equals 4, there is no way. So let's say for n equals 5, we have 5 positions: index 5, index 4, index 3, index 2, and index 1. And what comes here? For our normal solution, in which we were not making the condition valid for for this first number also, we would just put 1 at the last index at index 5, and for each other index we will take XOR of this number and this number and put it here, which is, in this case, XOR of 4 and 1 is 5. Then for index 3, XOR of 1 and 3 is 2. Then XOR of 2 and 1 is 3, yes, and then for 1 we will just put the remaining number, which is 4. But we cannot do that here because XOR of 1 with which number gives us 4. XOR for which we can just take XOR of 1 with 4, and it gives us 5. In this case, this does work. This does work in this case. Let's use this to find out for 9 test cases. 9. These are our solutions. Okay. This does work out somehow. Let's see for this number. Our condition is satisfied for all of these numbers. We have to check for this number. For 6, here the index is 1. So we are checking with which number should we take XOR of 1 to get 6. That number would be 7. 7 XOR 1 gives us 6, but 7 is outside our range. So no, that is not very good. And why must we use 6 here? Because that is the only number remaining here. Wait, there is a pattern. This always starts at 3, 2, 5, 4, 7, 6, 9, and let's find answer for a big number. There is just one test case, and the number would be, let's say, 20, and the pattern does seem to hold. 3, 2, 5, 4, 7, 9, and 8, 11, and all of these numbers. So there is a pattern which we get. But the problem arises that taking XOR, no, nope, this will not work when we want the first number also to satisfy our condition. So we cannot just use 1 here. We need to figure out some other thing. 7 would be there in this case. So here we are satisfied. Here we are not. Here we are satisfied. Here we need 8, 9. 9 is not there, so not satisfied. Here we are satisfied. And okay, so we had 4 satisfied. And then before this one, we had 4, 3, 2, 1, which is also not satisfied. So not satisfied, satisfied, not satisfied, satisfied, not satisfied, satisfied. Let's do this for more numbers, some experimentation stuff. Let's say we have 15 test cases, or we just have like 5 test cases. We have done till 9. Let's do 10, 11, 12, 13, 14. These numbers. And paste here. This is what we have. This and then this. Okay, so we had a pattern going on, and according to our pattern, this one should be not satisfied. Let's check, and that is true. We need 11 in our list, which is not there, so this is not satisfied. This one is satisfied, this is not satisfied, and this one is also satisfied. So if we can figure out a way to make these, so we have a solution for half of these, and we do not have a solution for the other half. And solution is always satisfied if we have n as an odd number. So we have for n odd, when n is odd, we have a solution, but when n is even, we do not have a solution. Okay, so we can figure out a way for finding a solution for odd, for even n, then it might work. And we have seen that in this case, when n is a power of 2, we have no solution at all. That is also something. Yo, does it not work for odd, like you are checking only for even ends? It does not work. It works for odd ends, but not works for even ends. Hi, did you solve yesterday's content? Yes, only 3. Oh, the last one is the array not at boundary. The last one is the array not at boundary. Hmm? I get what you were referring to. Okay, so we have to find out a solution for even n. Let's say for n equals 6. For n equals 6, our solution would be, we have to figure out 6 numbers. Index 1, 2, 3, 4, 5, 6. For using our solution for like easy version, we will have 1 here. XOR of 1 and 5 would be 4. This would be 5. XOR of 3 and 1 is 2. XOR of 2 and 1 is 3. XOR of 1 and 1 is 0, but we will use here the number which was not used, which is 6. So we need 7 here in the array towards the right of 6 to make this work. Therefore, we cannot use this here. Wait, shit. I wrote 3 in binary, my bad. 3. And this is the smallest number for which we do not have a solution, for which we have to figure out a solution, because n is at minimum 3, I think. Yes, n is at minimum 3. N is at minimum 3, then it is 4. For 4, a solution does not exist, since we are just assuming that this is a power of 2, and for 4, here it says we do not have a solution, so we are just assuming that a solution does not exist for a power of 2. We're just assuming. Then for 5, it is odd, we have a solution. Then for 6, we do not have a solution. So this is the smallest number for hopefully which we can find a solution. Or maybe it is that for every even number there does not exist a solution at all, no matter what we do. Maybe. Like 9 is within the array, just not at boundary. I was thinking you are making pattern like n and 1 at boundary. 1 at the right boundary. This is for C1. This is for C2. We are finding out solution for C2. For C1, we just put 1 at the last end, 1 at the last position, and we just take XOR of the index with 1 and put that number here. And that works out for C1. And at last position, if we were to take XOR of 1 with 1, we would get 0. So instead of 0, we are putting here whichever number was not used, and which is n, the greatest even number that is smaller than or equal to n, which we were able to see after some tests. Like, yeah, it seems like that is the way how it goes. Wait, so I think we can make this faster for C1. For C1, I think we can make this faster by we check. Yes, we are at work. Until this evening, we are doing work for submissions. This one took 62 milliseconds. Since there is a pattern to what the remaining number always is, for which we are using a bit set. We are like, whenever we are using a number, we put used equals to true, it, which is taking some compute. So instead of that, maybe we can always say res 0 is going to be depending on if n is odd. Question mark. If n is odd, then we use n minus 1. Otherwise, you use n. And let's see what the compute time for this is. Okay, it is better. Yes, memory is literally 0 because I guess we were using bit set before, but now we are not. And time is also better. So that is cool. We have saved like 16 milliseconds. That is worth it, I guess. 16 milliseconds. And now, okay. For even numbers, we do not have a solution. For even numbers, this does not work. And since this is the first number, we can literally put any other number except this, except the biggest even number. We can literally put any other number here and it would work, like, because all of the other numbers are to the right. And let's say we can literally put any other number here except 1, except 1, except 1, except 1, because for 1 we would need to have in XOR of the index with some number towards right, one of these numbers from the right. That should give us 1 if we were to put 1 here. And this would not happen unless we have 0 here, which we cannot have. So yeah, except 1 and the highest even number, if n is even. If n is odd, then it works out. And we can do some testing and we can assume that there is no solution for any of the even numbers, and we can just, whenever n is even, we can say -1, and whenever n is odd, we can use our formula for from C1 and use just that. But that is just working too much on faith. We have already assumed there is no solution for when n is a power of 2. Hello, shit, water. That is, it has been quite long. Camera quality has improved. It's because instead of camera, I'm using my phone as the camera, which is cool. So is has a solution. Uh, I guess. Yep. Let's keep going. For odd numbers, for odd values of n, we do have a solution. Okay, I do not just want to assume that if n is ever even, there is no solution. Not that we cannot get a solution, there does not exist a solution. We will not assume that. Let's see. For 6, for let's write a function that takes in a value of n and gives us a correct solution by random chance, by, yes, by brute force, so we need two parts. One function would keep generating new arrays, and for which there is a built-in function in C++ called next permutation. We can use this for for finding out permutations. I think this returns a boolean first, second. Yes, this returns a boolean. Yes, next permutation. Yes, we will use next permutation and next permutation for that, and we need a function that takes in our array and checks whether it satisfies this condition or not. Okay, let's write brute force.cpp solve for n equals 6, let's say, and here we'll say this takes in n. So we have n vector int a size n for int I, or we can use iota a dot begin a dot end starting with 1 while, or I think do, we have to use a do while loop here, do statement while next permutation of a dot begin and a dot end exists. Okay, and next permutation is in algorithms, which is included in bits. Okay, and do this. So we need a function bool is okay, which takes in a vector of integers reference a and tells us if this is valid or not. And time complexity of this is going to be n square a dot size. Int I equals 0, I is smaller than n minus 1, I plus plus. We will not go to the last number. For int I equals, for int j equals I plus 1, j is smaller than n, j plus plus, and bool found equals false, and if we want the current index, we want the current number, current number, which is AI, should be equal to XOR of current index if the current index is like one index, current index XOR with J, AJ, not single equal to double equal to. That is the case, then we will say found equals true and break. And what is the problem here? Okay, but if we come out on the other side and if and found nothing, if not found, then return false. Okay, I think this checks out. If okay, if is okay, A, then see out A. And how do we print our vector? Using this. Compile and run. And shit. There is no solution for n equals 6. There is no solution for n equals 6 somehow. See out. Let's see. Bool found equals false. And if we ever found a correct solution, we will say found equals true. And if we come out and we never found a correct solution, see out, no solution found. And let's, instead of giving in 6 for int I equals, we'll go from 3, I is smaller than equal to 10, we'll go till 10, solve for I. Compile. And this is not working. I think because there is a problem with this next permutation. Mhm. Next permutation, C++, let's see, CPP reference. Even though this does not make sense, like it is very hard to read CPP reference. Permutation range first to last in the next permutation returns true if such a next permutation exists, otherwise transforms the range into the lexicographically first permutation as if by standard sort and returns false. Okay. Okay, they have an implementation that is crazy. Example, yes. Do this thing while next permutation. Yes, this is exactly what we have done. I think we are getting stuck here or somewhere else, somewhere else. No, this, no, no, I think we are getting stuck here. See out? No. Or we can just give it here. Compile and run, and we do not see anything. Shit, literally, we are not seeing anything. Okay, because I am stupid, that is why we are not seeing anything. Here, the main function is waiting for t. Okay, there was no solution found for just 4, but we do have a solution for every other number. Okay, shit. So why do we print? Why are we printing all of these? Oh, C out N and a new line see out a new line after this. Let's see. Okay. For 6, we have a bunch of solutions. Okay. For 4, there is no solution. For 7, there are a lot of solutions. For 8, no solution. 8 is a power of 2. There is no solution for 8. Okay. Okay. There is no solution for 8. Then, according to our hypothesis, let's also break after this and check till let's say 20. There should be no solution for 16. Okay, it is taking quite a bit of time now because I guess time complexity. Okay. Uh, okay, it is finding for 12, it is finding answer. For 12, we do have a solution because this is like random. So, okay, this, yes, this literally is going to be very slow. This is going to be very slow because of obvious reasons. This is, yes. Uh, First of all, our algorithm for finding all the there are a lot of permutations. For n equals 13, we have 13 factorial permutations, which is not very good. And for each of these 13 factorial permutation, our function, which is checking if this answer is correct or not, it takes n square time. So n factorial into n square for finding a correct permutation using brute force. And yes, this is very bad. Even if n is very small, n factorial is very big for 13. Yes. And we are finding this answer because, like, quickly, because we are not going through all of the permutations. We are, yeah. Whenever we do find a correct solution, we just break and we move on to the next n value. So, okay, we didn't find a solution for n equals 4 and no solution for n equals 8. So it seems like for powers of 2, there are no solutions. Okay, but for even powers, we do have a solution. For n equals 6, this is the solution. Or this is like one of the solutions. Let's find all of the solutions for n power for n equals 6. Solve for n equals 6. Give us all the solutions. And these are all the solutions for n equals 6, which work. Okay, now we have two ways of getting to a algorithm. I think one would be like thinking about what the problem is and everything, and other would be going through the solutions and finding similarities between them. I think which is also works, which is fine. So this is for n equals 6, all of the solutions, all the valid solutions for n equals 6. Let's also look at all the solutions for n equals 10 because there are no solutions for 8. There are only solutions for 10, and there are a lot of solutions for this. Copy, paste them. Shit, there are a lot of solutions for this here for n equals 10. There are a lot of solutions. Let's also print the number of solutions. Uh, and count equals 1, and before this, cout count and colon. 108. There are 108 solutions for n equals 10. Okay. 8. There are 8 solutions for this. And we have 1. Instead of 1, we have all the numbers. Okay, we have from 2 till 5. We have all the numbers here. Right. 2, 3, 6, 5, 1, 4, and 2, 3. Okay, here also we have 2, 3, 2, 3. Here the difference is 1. Here the difference was 3. And difference 1. Difference was 7. Here also difference is 1. Here difference is 3, 3, 1. We are looking for patterns here. Here difference is 1, 4, and 3. We do not have a solution for the highest power of when n is a power of 2, when n equals 2 power something like x, we do not have a solution. Maybe here we have 4 here. Okay, let's say we do put 4 here. Okay, for n equals 6, for n equals 6, we put 4 here, not 6, but we put 4 here. 4 here, 4 here transformation. 6, 5, 4, 3, 2, 1. Then the only number which can come here would be XOR of 4 and 5, which is 1. Yes, 1, correct. And then here we will not take XOR of shit. After putting 4 here, we have 1, and we can keep taking XOR of 1 with all the numbers as if we are cool. Shit, except for this number, except for this. Here we will have to use, I think, 5. No, shit. Okay, for 4, here we can take XOR with 1. We will not take XOR with 4 because that gives us 0. So we'll take XOR with 1, and that gives us 5. Yes, and for 3, we can take XOR with 5, 1, and 4. If we take XOR with 1, we get 2. If we take XOR with 5, we get 1, 0, 0. We get 4. And if we take XOR with 4, we get 7. Yes, which is outside our range, so 7 does not work. 2 and 4 are things which can work here. 4 we have already used, so no. 2 would be the only choice then. And then for 2, we will not take XOR with 2. We can take XOR with 1, 5, and 4. If we take XOR with 1, we get 3. If we take XOR with 5, we get 7, which is outside our range. If we take XOR with 4, we get 6, which is within our range. So we can use 3 or 6 here, only 2 choices. Okay, and then when we are at, so we can use 3 or 6 here. Then 1, when we are at 1, we can take XOR with all of the rest of the numbers except 1 and 6. So for 2, we will get 3. Okay, 3 works. We can use 3 here, and we can use 6 here. Or we can not use 6 here. Yes, we cannot use 6 here. Okay, this is one valid solution. 3, 6, 2, 5, 1, 4. 362514, which is different from this, and it differs at this point, third point, at index 3. Here we have 2, here they have 6. How can they use 6 here? 3 XOR 6. 3 is 1 1 and 6 is 1 1 0 0. This gives us 1 0 0, which is 4. 4 we have already used. Shit, yes. Therefore, we can use 6. We can use 6 because we can take XOR of 3 with 4 and we will get 6 here. Yes. Okay. Mhm. Part 1 was straightforward enough after giving it thought for like 1 hour, but part 2 is more difficult. Hello, the code guy 01. Shit, the family guy, code guy. Bro, I'm struggling in to understand question in CF, not the answer, just the question. What is your advice? My advice or my observation is that in yesterday's contest, problems were like very not clear. Even question number 1 was not clear. Like, look at this. Internet is slow. Uh, Questions were not clear. Problem statement were not clear. And I think they are doing this intentionally because so that people do not use AI or something for cheating. This is not very clear. Ned can choose 2 power k smaller than n numbers from his array and split them into k pairs. After that, for each resulting pair xy, he takes the cell located in row x and column y and adds 1 to the number in that cell. If the cell does not exist, then this pair does nothing in the array. And yeah, this is not very clear in the like first read. You have to read this a couple of times. And for question number B, it was even less clearer. For question B, it was even less clearer. And yes, the advice would be just to read problems. Yeah, over time it will start making sense because we are not used to talking in terms like this. Choose 2 power k less than equal to n. We are not used to you to being talked to like this. Like, look, this is like way too worse. But magic always comes with a price. It has been cursed. Before each bith attempt, before bith, 2 bith, 3 bith, etc. attempt among jumps of type I to use the ith type of jump, the frog rolls back ci units. In other words, if it was at point k, it will first find itself at point k minus ci, and after the jump, it can land at any integer from point k minus ci to k minus ci plus ai. What are all these variables? Yeah, and so you just have to read problems and do. Like after some time, it will make sense. Exactly, I think yes, and I think it is problems which are in this lower rating, 800 to 900. Their statements are weirder, are like yes, very unclear nowadays. They are very unclear, very unclear. Like, it took me 10 minutes to understand yesterday what this problem even means. What are they asking for? Like, look at this. Before each bith attempt, before each bith attempt, if you take this on face value, this means if you have like if, for example, if let's say bi for some I is let's say 4, then looking at this, before each bith attempt, I understood that before every fourth attempt, if bi is 4, before every fourth attempt, it means at attempt number 4, at attempt number 3, at uh, attempt number 1, 2, and 3, which are before attempt number 4, this thing which they have said, like a rollback will happen for all of these attempts. But that is not what they mean. What they mean by this is that at every fourth attempt, a rollback will happen. 5, 6, 7, 8. And not just at every fourth attempt, every multiple of fourth attempt. So for 1, 2, 3, there is no rollback. At the fourth attempt, there is rollback. So instead of before, they should have, if they had used at instead of before here, at each beat attempt, a rollback happens. That would have made more sense, right? 1, 2, 3, there is no rollback. At fourth, there is a rollback. 5, 6, 7, no rollback. 6, eighth, there is a rollback. Like that would have made this a bit more clearer. But yeah, these problems are difficult to understand. Not just the solution, they are just difficult before getting to a solution. Yep. And yeah, I would just say you have to like get on with it by reading and solving more problems. That seems to be the only solution in this case. And before moving, before like putting more time to this problem, let's see, do some stalking. We will do some stalking. Standings. We will stalk some people. Let's see. Share. We have Igor. Igor is the person. Okay, shit, this guy is Igor. But Igor or Igor. Wait, it was not in question 1, then it must be in question 2. There was a person's name was Igor in one of the problems. Shit, there is no one named Igor. Shit, there is no one named Igor. I thought there was a person named Igor in one of the problems. Okay, let's look at some other people's solutions. Kesun. Kesun seems like a nice guy. We look at his or her solution from Canada, MIT. Uh, I think we can just look at the solution by clicking somewhere here. There is a way I think we can like just click somewhere here. No, we have to go to his profile, it seems. All. And this was the problem. He solved 8 for question number 1. Let's see. This is his or her solution. N, H, and L. Take them. Input the array completely and x minus minus to make it okay, because x minus minus. Why x minus minus? Because they will use H and L as 0 indexed. Okay. Shit, this is exactly what I did. Shit, okay. Okay. H greater than L, then swap. So we want H to be smaller and L to be greater. Then sort this whole thing. Okay, that also makes sense. Okay. And then answer equals 0 initially. J will go while, okay, we are only going halfway through the array. But this is a nice way to go halfway. Instead of using n by 2, we can use 2j here. If index is smaller than n, and okay, if 2 into j is minus 1 is smaller than n, right? Which means j is not exactly half of n, and we have a j minus 1 and a 2 into j minus 1, okay, which is within the range we checked from here. and this is smaller than L, then answer increases. Else we break, and they have swapped this whole thing. Okay, we are looking at the current number and the number on the opposite end. Okay, let's test this theory. We have a number like this. We have a list. N, H, and L. Let's say yes for this. This is H, this is L, and we want L to be bigger. So L is 4 and H is 2, H is 2. Okay, they have sorted this whole thing. So we have 2, 2, 2, 2, 3, 4, 4, 7. And they, that person, he is moving from this. And this is like two-pointer method in some ways. Okay. And they are seeing this number smaller than H, and this number smaller than L. If that is true, which it is not in this case, so we say 0. Wait, shit, this would say 0. This is 1, 2, 3, third. But for the third one, answer is not 0. The third one answer is 3. We are messed up in the implementation. Sort beginning to end. Okay, they are not going to the 0th place. They are starting from j equals 1. They are looking at this number and j. Okay. Let's say for j equals 1, we will look at a 0 j minus 1 and a 2 into j minus 1. 2j minus 1, j is 1, so 2j minus 1, 2 minus 1, 1, which is this number. And yes, this checks out. Both of these, this one, smaller one is smaller than this, and this one is smaller than equal to this one. So yes, answer increases by 1. Then j becomes equal to 2. Here we get here. So j is now 2, and we look at a1, which is 2 minus 1. Yes, we are only increasing j by 1. So a1, which is 2, which is this number. And we are looking at a 2j 4, 4 minus 1, 3. Which is this number. This is not making sense. Like, I think, I mean, if we were to actually go through this whole process manually, this will give us the right answer because this did give the right answer. But how does someone come up with a solution like this in 2 minutes after reading the problem? That is the difference in the level, I guess. Thank you, bro. I thought I was alone and dumb, a common feeling, because when I see people looking at problems and straight to go on to solution, those problems, I sometimes spend days at particular. Yes, that is what happens. Hello. Like, cool, it is cool. Like, yeah, don't worry, it is cool, normal behavior. I'm new to Code Forces. Can you explain me in a short while what platform is like? And I have so far only used Lead Code. Okay, so on this platform, Code Forces, you like make your idea and stuff, and then The main thing is contests here. There are contests, like yesterday was a contest, and in a contest you participate, you register your name and participate. And this contest began at 8:05 in the evening PM in India. And what happens is it, you are given a bunch of problems in a contest, starting from the easiest problem, problem number A, not problem number, problem alphabet A, and then problem B, problem C, and stuff like that. And when you solve a problem, you like submit your solution, go there, like write your solution, copy paste your solution from your editor here and submit it. And after the contest, depending on how many problems you solved and how much time it took you to solve those problems, you get a score. Your rating either goes up or goes down. Like for me yesterday, it took me 14 minutes for the first problem, and this time is calculated using uh, using the like start of the problem, start of the contest as 0. So when the contest was like 14 minutes in, I submitted my solution for problem number A. Then for problem number B, I submitted the solution at 38 minutes, and for C at 1 hour and 17 minutes. And there are scores. In some problems, there are a score and there are other metrics for calculating how much your standing should be. So after your solution and stuff, you get a ranking. And look at this. There are these people. This person got like rank number 1 in the contest. He solved the first question in 2 minutes, the second question at the 6th minute, the third at the 11th, and so on. So like, yeah, he's pretty good. And yeah, then you get a rating change up or down. Your rating goes up or down. My went up yesterday, and yours might also go up or down depending on your performance. And the thing is, just like you get better at solving problems, and you can boast about your rating to your friends who don't even solve code forces, and like code forces does not even matter to them. You can boast about your rating on code forces to them, and you can just like flex with them. Yo, yep, positive noise. It's like lead code and just a bit harder questions and problems are related. Like in chess there is elo. Yes, like chess, in chess we have elo. Magnus Carlsen has not been able to defeat me. Like, yes, he has never defeated me. So yeah, that is a achievement, I guess. Okay, so we did some stalking. Let's do some more stalking. Standings. Yes, it is pretty cool that you can look at other people's solutions after the contest. Like, his solution didn't make sense. Wait, it was Ksun's solution. Let's look at other people's solutions. Ksun, potato 167. Masby, I've heard Masby burnt chicken is cool. And I'm looking for mm, shit, where is Jiang Li? Jiang Li is a nice person. This is how he looks like in real life. Jiang Li, I think he didn't participate in yesterday's contest. He must be up to something else. Yeah, and also one more thing about Code Forces is that it is very slow at times. It can be very slow. Like, look at this. No, I was talking other people who are better, like from leaderboard, and I would also like to stalk you if, yeah, shit, he lost some rating, Jiang Li. Okay, he didn't participate yesterday. Let's look at this person's solutions. Legendary Grandmaster sheet. Hopefully we will also get there someday. Let's look at their solution. Okay. Okay, that is crazy optimization in one line, like code golf. Okay, int TNHLIA C1 C2. NHL C1 C2 equals 0 for int I. Okay, taken C and yes, yes, this is literally what we did, C1 and C2. And yes, minimum of these two, or take maximum of these two and half. Okay, this part does not make sense. Take maximum of C1 or C2 and do half. Take maximum of C1, C2. And this is helpful. You can say that uh, since like I did solve this question yesterday, so what is the point of looking at other people's weird solutions? But the plus point in this is you get a new model of thinking about the things that you already know how to think about. So that is good at times. Like this thing, uh, like if you are printing an array, I equals 0, I smaller than n, let's say I plus plus. If you are printing an array, let's say AI, and when you are printing an array uh, and you want to put spaces between the elements and a new line at the end of the array, normally what you can do is, what you would do is this: put a space after each element, and after you have printed all the elements, then put a new line here. But yeah, this is like noob way of doing things. And then once I was reading Jiang Li's code, and there I saw he was doing this to print new line at the end of the array. For all values of I which are smaller than n minus 1, we will print a new a space, and then for the last element we will print a new line. So that is pretty cool. So you only did min and it worked. No, I did min plus, oh, shit, the order has changed. I did min this thing plus half of min plus half of C2 minus min, if that makes sense. I mean, that is not necessary, just for safe answer, like he must have solved very fast, and that is how I do now for printing. Yes, that is also my default now. It just looks very cool. And also there was once I saw that if you have a array like this, one like this, and you want to find out all of these sub arrays, all of these segments, you want to find out all the segments which have the same elements here, right? You want to find out like that there is a segment whose length is 2 and the elements in that segment is R1. There is a segment of length 1 and there is 2 in it. There is a segment of length 4 and there is 3 in it. There is a segment of 4 whose length is 3 and segment of 7 whose length is 4. For this also I saw in Jiang Li's code. So yeah, Jiang Li is pretty cool. L equals 0 and R equals 0, while R is smaller than equal to n, uh, and L equals R, what we can do is, while R is smaller than n and L equals A R plus plus. And so initially both of these L and R are pointing to the first element, and we are moving R towards right till this element at this at the cursor is equal to the element at which L is at. So and when we get to this point, to this element 2, to this element 2, we will exit this loop. So when we get out of this while, either R is pointing to a element that is different from the element that L is pointing to, or R is pointing out of the vector because of this condition. So then the size of the segment would be R minus L, and the elements in the segment would be A L. And since here we have written L equals R, since we have written here L equals R, L would also start pointing to this element, and for 2 we will get a size of 1 because R will go to 3 and stop there, and index of this thing minus index of this is 1. So yeah, there's like cool tricks you can discover by reading other people's code. Yep, 2 pointers. Like normally what people do is L equal R after the loop break instead of L plus equal to R after the loop break. This thing instead of L plus equals R. Don't get this point, but yeah, 2 pointers. I didn't know this thing before, but this is cool. And for so C2 is max in this C2. Okay, since he has not specified whether H or L, which one is bigger in them, he's just counting count of these numbers which are smaller than H, and count of numbers which are smaller than equal to L. So okay, they can be anything. And why does this work? Because I have made it so that H is always smaller than or equal to L. So in my case, C1 would always be smaller and C2 would always be bigger. Let's say it is the case. Then C2 would be smaller and C1 would be smaller and C2 would be bigger, and minimum of these two. Okay, minimum of these two. Okay, minimum of these two, or maximum of C1, C2, and half. And we are taking minimum of both of them. This actually does not make sense to me. Let's look at his solution for the second one. This problem, star silk. Let's look at burnt chicken. Wait, that is not very clear. Okay, is he complaining here like that he solved more questions than this guy above, but that guy is still above him? Um, all 7. That is a lot of boilerplate. Mango. Let's see mango. NHW, height and width. Okay, swap. Yes. So that W is always the bigger thing. H is the smaller one. C1, C2, rep N. Okay. Repeat this thing n times. You can just write a for loop without this. Okay, int x, take in x if, okay, increase c1 and c2 Okay, this is closer to what I have written. C1, since C1 is always smaller, minimum of C1, if C1 is minimum, or C1 plus C2 divided by 2. Okay, let's look at this visually. We have a bunch of numbers and h is smaller and L is bigger. C1 is all these numbers which are smaller than equal to L, and C2 all these numbers. I think I made this the wrong way, but okay. And he has written that C1, which is the smaller number, that's labeling is wrong. C2, C1, C1 minimum of C1 or C1 plus C2 by 2. C1 plus C2 by 2. Why would this work? Let's use some actual values. Let's say C1 is 2 and C2 is 4. So there are two numbers which are smaller than equal to h and four numbers which are smaller than equal to L. So two numbers here, two numbers in this range. So C1 is 2, this thing where C1 plus C2 divided by 2, this would be 3. 2 plus 4, 6 by 2, 3. And answer we would say is 2, which is 2 because we can pair up these two numbers with these two numbers. Answer would be 2, 2 pairs. And if we increase this any number of times, does not matter because we won't be able to make extra pairs because there are not enough numbers here. And if we increase here numbers here is let's say C1 equals 4 and C2 equals 4, which means there are four numbers in this range but there is no number in this range, right? So C1 is 4 and C2 this plus this divided by 2, so 4. 8 by 2, 4, but that, and C1 is also 4, so minimum of 4 and 4, that would give us 4, but that is not the correct answer in this case. Answer should be 2. And he literally uses a function called print. A minimum of C1 plus C2 divided by 4. Okay, C2 refers to only the numbers which are bigger than H. And okay, in this case, our C2, I was considering C2 as all the numbers which are smaller than L, smaller than equal to, which would also include these numbers. So according to his definition, C2 would be these numbers. So okay, either there are now only three possibilities, C1 equals C2, in which case we would be able to pair up every number from C1 to C2. So yeah, answer is C1 plus C2 divided by 2, and C1 is also the correct answer because C1 equals C2. But if C1 is greater than C2, then we will be able to pair up, we will pair up all the numbers, all the C2 numbers, and we will have C1 minus C2 numbers remaining. So answer in this case would be C2 plus C1 minus C2 divided by 2 and 2C2 plus C1 minus C2 divided by 2, and that is just C1 plus C2 by 2. Shit, okay. And C2 is greater in this case. And the third case would be C2 is smaller than C1 is smaller than C2. Then we won't be able to pair up every number from C2, and the answer would be C1 in this case. Okay, but we reached at this formula after going through a little bit of algebra. But this person was able to like perceive this as the correct solution in 2 minutes. So maybe this is a like normal maths thing which we don't know about. Yep, lazy. Slightly changed in ordering. Yep, yep. 2 pointers moving forward. So for like 7, 4, 7, he did 7 by 2 equals 3. Answer you got 2 equals 3. Wait, huh? Wait, this is wrong maths. Okay, without bracket. Wait, shit. I think yes, you are right here. 7. This thing. Okay, okay. X plus y minus x by 2. This thing is equal to x plus y by 2. Yes, this makes sense because we have here y by 2 minus x by 2, and x minus x by 2 is x by 2. X by 2 plus y by 2. Yes, makes sense, makes sense. No, it is I use Lazium just for adding plugins, but nothing else. Everything else is like self-written. It is, yeah, which is nice. My own config neovim in Lua. I don't know, Lazium though might be same. Lazium is a plugin in Vim itself. It is not a separate program, it is in Vim. But people use it, people use Lazium who do not want to write their own configuration or who are just being a bit lazy. Yes, literally, who are being a bit lazy. But yeah, I do not like using lazy Vim. Write your own configuration for Vim if you are using Vim. If you do, it can never be never be smaller than minimum. C1, C2, no. Never be. Wait. Wouldn't this always be smaller? C1 plus C2 by 2 can never be smaller than minimum of C1, C2 if we are adding x1 plus or x plus y by 2 is always greater than min of x comma y. Okay, we are adding x by 2 and we are adding y by 2 together. If x is some number, shit, yes, it can never be smaller. It can never be smaller. Let's say if x is smaller, yes, we can use lines to show this. Let's say this is x, this is y. If x is smaller, or does not matter which number is smaller, let's say the smaller number, we are taking its half, and for the bigger number also, we are taking its half. And this pink line is greater than the green one. Let's say by this much amount. So minimum would give us 2 green lines. when we take the minimum, this would give us two green lines, this, and the maximum would give us, and um, this part would give us two green lines extra this portion, this red portion. So, yep, that is correct. Yes, it can be equal. It can be equal at max. Yes, when x1 equals x2, then this red portion would be 0. And I should probably put my phone on charging. Yeah, now like back to actually discussing the problems. Yeah, other people's solutions don't always make sense. But at 167, let's look at his solutions. Bruce solved all of them. Heavy boilerplate. Dear mysterious Tomo. Swap, taken, rep. So A. Sort. A. Upper bound. Upper bound. I don't like boilerplate. Yeah, yeah. These don't have to make sense. Let's read the editorial then. Let's see. There might be something. Nah, I don't want to read the editorial for this one. For frog, no. Frog also did made sense. For yes, this is the problem. C1, for which I would like to read the editorial. But yes, for yesterday's problem contest, problems were not clear in their English. So second condition is in their answer is pointless. Wait, that is what you were referring to. In burnt chicken. This, wait, he is from Taiwan. That is actually crazy. Pro is going to be attacked by a whole nation. Okay. Minimum of this or this. That is a nice observation. See, but here, yes, we do not. Do we not know? Would it even matter? Yes. This would always be minimum. This would always be minimum. This would always. Wait, no, if C2 is, let's say, 7 and C1 is 1, then yeah. If C2 is 7 and C1 is 1, then this would be 4. Yeah, this is bigger, so still this would be minimum. Still this would be minimum. They can say 1 is the answer here. Shit, yes, yes, that does make sense. That does make sense. So C1 would always be the answer. C1 would always be the answer. If C2 is, if C1 is 7, yes, if C1 is 7, if C1 is 7 and C2 is 1, then this would be the smaller number. Yep. 7 plus 1, 8. 8 by 2 is 4. 4 and 7. 4 would be smaller. So yes, this was not pointless. This was not pointless. Bro had some plans. Wait, then if that is the case, then what what did we conclude here? If here we have that y is smaller. Yes, yes, there are conditions here. We arbitrarily chose that y is greater. If y is smaller than x, yes, if let's say x is this much and y is smaller than x, then when we are looking at half, this would be half and this would be half, and for y this would be half and this would be half, and when we are doing x by 2 plus y by 2, we get this half, smaller half, plus this bigger half. Yes, and we are just comparing with x, and x certainly is bigger because x is this bigger half plus this bigger half, and this half, this is bigger than this, therefore in this case this is x, x is greater than this number. So we messed up, a little bit. Hello, at the end of the stream, shall we try at Coder's Beginner Contest 309 problem E? And just give it a try and give a small hint for it. But, like, why are you assuming that I will be able to solve it by default? Don't give solution. If I do get a solution, maybe. Yes, we will look at that. For now, let's like get back to the track, and I want to read this. First, note that pi equals pj, XOR with I is equivalent to, yes, yes, like we didn't explicitly say this, but yes, this was the idea. Pi XOR I should be equal to some number to its right. For I equals n minus 1, the only possible j is j equivalent. Yes, yes, j equals n, yes. Let's try to construct a permutation such that for all I, the corresponding j is j equals n. That is, we want to ensure that for all I greater than equal to 2, the condition, yes, and the condition pi XOR I is pn, the last number. Yes, we did that, and we put last number equal to 1. Take pn equals to 1, yes. Then we notice that at position 2k, the value must be, if k is even, yes, k plus 1 at maximum, and at position 2k plus 1, the value must be at position 2k plus 1, an odd position, the value must be 2k plus 1 XOR 1, which is 2k, and here it is 2k plus 1. Yes, here it is 2k plus 1, and at odd position the value must be 2k. Okay, thus the numbers split into pairs. Okay, 2k and 2k plus 1. Okay, let's examine two classes. If n is even, take p1 equals n. Yes, if n is even. If n is odd, n is odd, yes, n minus 1, and p 2k, oh, I don't get this, permutation 2k at some kth position. K is some arbitrary number within this range 1 to n, and by 2, 2k plus 1 at all the even places, put the value even number plus 1, and at all the odd places put the value, the index -1. Okay, and if n is odd, then put the biggest even number at the first place, and then all the even places all the even places put 2k, the even number +1, and at all the odd places put 2k. Okay. Okay, this is similar to what we did, but they have begun from p1, we began from pn from the last number by putting it equal to n. Okay, and this is their code. Please wait, they are checking the browser. And this is their code for the same conditional logic. R begin, R end. Okay, I want to solve this one. Yeah, not right now. Let's solve your problem. EBC. How often do you review unsolved problems? Do you keep track? No, I do not keep track of them. That is like too much work. It was pointless. For if we do minimum, then max part is pointless. If we do minimum of C1 and C2, then max part is pointless. It is. Have to look at his code again. But I think I can just look at the solution by clicking here. Yes, shit. Oh, yes. I have to click here at this area. Yes, and it works. Okay. Here's the solution for the first one. Yeah, here it is okay to take minimum, but if we take max of those two numbers, I don't get it. Cannot hear you. Hello. It is working. The mic is working. Shit. Wait. Is it working or not working, or are you trolling? Maybe in code forces, how do you look at someone else's solution? Can you show? Yes, I just figured it out. We don't have to go to their profile. We can go to the standing and click on like in front of their name here twice, and there are all the solutions. It's solution for problem A. Look at this, and yeah, that is pretty cool. That is pretty fast. From OBS, the like voice bar is as high as it can be. It cannot go higher. So I guess maybe increase volume on your side a little bit. And okay, ABC 309 problem E, encoder ABC 309. This one. Yes, beginner contest 309. Problem C. Tasks. Yes, I do have ID here at school. Medicine. Let's see. Let's also have a stopwatch. Okay. New on. Uh, Sakuna. Sanook, the doctor, prescribed n kinds of medicine for Takahashi for the next AI days, including the day of the prescription. He has to take BI pills for the next AI days. He has to take BI pills of the ith medicine. He does not have to take any other medicine. Okay, let the day of the prescription be day 1 on or after day 1. When is the first day on which he has to take K pills or less? Okay, for ith medicine, he's telling he has to take BI pills, and ith medicine has been described for AI days, including the current day. He does not have to take any other medicine. Let the day of the prescription be day 1 on or after day 1. When is the first day on which he has to take K pills or less? K, N and K. N and K. He has 4 medicines. This one has been prescribed for 6 days, and he takes 3 medicines each day. And okay, if that is like the question, then for the first day he will take all of these medicines, which is like certainly greater than 8. Then on day number 2 he doesn't have to take this one, so he will take 5 10 medicines. On day 3 he will not take this one, and answer should be day 3. Answer is day 3 for this one. 100. Day 1, day 1 is the answer. It is that the actual problem? If that is the problem, then let's look at this. On day 1 he has to take 3, 5, 9 and 2 pills of all of these medicines respectively. In total he has taken 19 pills, which is not less than or equal to 8. On day 2 he doesn't have to take 9 1. Okay, so okay, at least my understanding of the problem is correct. Then can we go day by day? We literally can go. We can go day by day. We can go day by day. Binary search. Okay, shit. No. Okay, E. Okay, my bad. My bad. Wait. Let me solve this one like this things. Okay, here we can go day by day. My bad. Timer is also running. We can go day by day here, and yes. Wait, shit. Yes, we do not have test cases in here. So int n and k, taking n and k, and okay, vector of pair int a n, and does not matter. For int I equals, okay, shit, yes, we a few days ago I made a post on how we can iterate through a map using unbinding, structure unbinding or something. So we will use the same thing here for auto reference yes, a comma b in a, shit, let's use x and y. You can just do take in x and take in y, and this works. Instead of doing we either could have gone index by index, or we could have gone here by saying like x, and in which case we would have to do x dot first and x dot second, but this is like much more cleaner. Okay. And then I guess we would like to sort this thing. Sort a dot begin and a dot, depending on the days, a dot end, where we will give a lambda function. Yes, a lambda function. Lambda function. This takes in two pairs auto P1 and auto P2, which we can also destructure right here, like x1 and y1. I think we can destructure. No, we cannot destructure them here. P1. No, we also have to do, I think, that, no, we don't have to do this. Return P1 dot second smaller than P2 dot second, and move this. Okay, so this is sorted, and long Sn equals 0, and we can put this here, and Sn plus equals y, Sn plus equals y, and int I equals 0. Yes, we can go day by day. For int I equals 0, I is smaller than n, no, not n. We'll use a while loop here. Can we initialize I inside this while loop? While, yeah, while. Okay, now. And I equals 0, and while true. If we are at day 1, res is at least 1. Day 1, yes, day 1 sum is sm if res smaller than or equal to k, then break. Otherwise, index I is pointing to the I is pointing at a nice place. Okay, we'll move forward till we find our day, which, wait, we will use that same thing. Shit, yes, we will use that same thing. Int L equals I, the same thing that we were looking at a while ago. R also equals I. R smaller than, we'll just break out of this. R equals L, or like L equals R, right? Here, while R is smaller than N, and A R dot second equals A L dot second, whatever this, not second but first. Okay, and this will give us the range. Okay, range of days, and current sum equals 0, while that is true, R plus plus, and C sum plus equals A R dot second. And when we get out, yes, and that's plus plus. Still, if this does not matter, we can just remove all this. Int L equals I comma R equals I. As we are increasing C sum, and yep, we have to do sum minus equals uh, SM minus equals C sum, not while true, but while sum greater than K. This should work, hopefully. Hmm. If there is an error, why are we not getting that here? The way we are passing the lambda function, maybe. Shit, SECOND. Why did this thing not give us some error? Wrong. That is correct by default. My like chance, I guess. This says 3. Okay. I rage quitted this contest last night. Just could not keep torturing myself. Lol. Yes. If you do read the first question, it is like very vague and very not unclear. It is very unclear. Is it that you have set up C++ starting in NewVim for when you do code forces, or is it a NewVim feature? No, C++ starting. Set up C++ is start. Okay, I have no. It is not a NewVim feature. I mean, this thing that you are seeing right now, this is a plugin, and there's other things that I have written. Some like key maps which I have made in NewVim, which are pretty cool. You can just compile the code that is given to you, and cool. Yep, plugin. An extension from web store that part. And yes, also this thing is a two-way thing. You need to have this on your browser and a plugin on NewVim which catches the signal that is being sent by this plugin. Okay, yes, that is a nice thing. Here, NewVim options. If you go block, yeah, and you can do this. NewVim option GUI cursor in normal mode. I want my cursor to be of type block. And virtual edit block, this is something else. But yeah, you can just do this in your NewVim config. Paste this n block. That is cool. And back to this. I think this is cool and this should work. And this does not. Shit. Because we don't even have to use this lambda function here. My bad, because yes, we want to sort using the first element in the pair. Still wrong answer. I is not changing. After this, I equals R. Sm should be greater than K, and res is increasing. One does not make sense. Res is smaller than K. Okay, that is a stupid thing to check for. Okay, 2. That is some progress. No, put this around here. Sort. Okay, we would have 1 9. I 0 would be pointing to 1 9. R would become 1. I would also become 1. Res would also be cool, and C sum, which is initially equal to 0, would plus equals R. Yes, R dot second, which is 9. C out. Um, Asim, SM is 10, which is why did we break out of this? 10 should not have worked. LSM is greater than K. 10 should not have worked. Why are we? Why is there a break statement here like this? Just a random break statement. Correct. Correct. And this should have worked, but no. This is 10. 10 is not correct. 10 is not correct. Shit, yes, 10 is not correct because I is not equal, I is equal to R, but rest does not increases. Rest equals AL dot first. AL dot first plus 1. Yes, yes. So. And yes, finally, 18 minutes. After 18 minutes, this we don't even know if this will work. C++ 23, only option. Wait, hello. Shit, you have been here for a while. Shit, I didn't read your message before. If medicine equal prescribed. Hey, correct answer. Yo, accepted. Cool. Uh, if medicine equal prescribed. Medicine prescribed. Okay, maybe I guess you're trolling here, and this does not make sense to me. Yes, I do use the keybind. It is cool. Uh, Compile. It gives also gives the compile time. And wait, what was the actual question? He said E. Yes, like yes. Now E. Now E. Problem E. Family and insurance. Okay. And I must stop. Restart. Before moving on, I would like to go to the washroom and write back. Just 1 minute. I'll be right back, and we'll do problem number E. Yes, I thought so. Yeah, I'm back. I was just scrolling. 1950 is a good time, I guess. 7:50. Wait. Do we have to talk? Shit. Do you want to talk? Shit. Yes, we can. We can talk today. This problem. See, 20 minutes is like you are around 800. Yeah. No. Yes, I guess. Yeah, I'm not that good. Okay, but there is also performance pressure, right? Like total 7 people are watching. I'm under pressure. Problem statement. And there is a family consisting of person 1, 2, and person n. For I greater than equal to 2, person i's parent is pi. For I greater than equal to 2. So for person 1 has no parent. Batman. They brought insurance m times. For I to m. Okay. Person xi bought the ith insurance. Okay, which covers that person and their descendants in the next yi generations. How many people are covered by at least one insurance? Okay, we have people 1 to person n. For I greater than equal to 2, i's parents is pi. Okay, we have a list pi listing all the parents, and somehow person 1 does not have a parent. And then we have they bought m insurance m times. Who? They. For I equals 1 to m. Person xi bought the ith insurance. Okay. Okay, this person bought this insurance and this person bought this insurance, which covers that person and their person's descendant in the next yi generations. Okay. How many people are covered by at least one insurance? By at least one insurance. This person does not have a parent, and this person's parent is he themselves. Uh, this person is their own parent, and this person's parent is one. This person's parent is this. This person's parent is this. This person's parent is also this. This person's parent is this, and this person is their own parent. And this person bought insurance, which is this one and this one. And the fourth person also bought insurance, which is this one. And by at least one insurance, or how many people are covered totally. This is a graph. Because of this insurance, only this person is covered because they do not have a like generation. So one person because of this insurance, and one person because of this insurance, and second generation for this is, wait, this is the first generation and this would be the second generation. So 1 and 3, these 4 people have been covered in insurance. First insurance covers people 1, 2, and 4. Second insurance covers people 1, 2, 3, and 4. This insurance. What M insurance is? Xith person bought the ith insurance, which covers that person and their descendant into the next yi generations. Next I generation. So this person bought insurance, and it should only cover this person and this person, because this person is not in their generation. Person number two, people number two. Okay, yes. Before four people, one, two, three, four were covered. One, two, three, four. Covers people one, two, and four. How is two covered? How is two covered? How is the parent-child relationship for I greater than equal to 2? I's parent is PI. Is person PI. I's parent is person PI. And here I is 2 and two's parent is 2. Okay. Maybe I'm not understanding. Huh? Shit. Bro's being doxed right now. How is this possible? Maybe yes, probably I'm not getting this. Second person's I is 2 here and two's parent is 2. And first number one insurance covers people 1, 2, and 4 because person one's first generation descendants are people 2 and 4. This person's first generation descendants are people 2 and 4. Shit, this begins from here. Okay, shit. This is people 1, this is person 1, this is person 2 because this is P2. Okay, this is person 2, this is person 3. Okay, okay, let's write a graph. Can you draw? We have person 1, person number 1 has two descendants, person number 2 and 3, 2 and 3, and yep, person number 2 also has descendants, person number 3. Wait, what? This is person number, wait, 2, 3, 4, 5, 6, 7. Okay, person number 2 is a child of person number 1. Person number 3. Okay, so this is person number 4. 4. Okay, person number 2 has 3 as their child. Person number 4 has 1 as their child. Person number 5 has 3 as their parent. So 5, 6, and 7. They all are here. And the insurances are as follows: 1, 1, 1, 2, 4, 3. 1, 1, 1, 2, 4, 3. 1 for the next one generation. This covers this, this, and this. This insurance covers 1, 2, and 4. And this insurance covers the next generation also, which includes 3. So 1, 2, 3, and 4. And this insurance covers for person 4. Person 4 has no one in their generation. So just one person, which is person number 4. So in total, there were 4 people covered. We just have to make a graph. And shit. And what is the maximum value of M? M can be 10 power 5. We cannot just go for each insurance. First, we will make a tree, but for each insurance, we cannot just go through the tree, which is not, it is not very good. Can we store information like for a certain person, for ith person, give me how many people are in their nth generation? yi can be very big, like something like this. If we do store something like this pre-hand, we would, what is the maximum value of I? Maximum value of I is n, 10 power 5, and maximum value of n, their next generation, is also 10 power 5. So yes, 10 power 5 would be total time, 10 power 10 would be total time complexity if we were to fill this. So we will not fill this. Yep, we will not fill this. Here we can do a little bit of optimization, like here we have this and this. So we will only look at the insurance which has higher number of generations. We will not look at this insurance. We can make a tree for this, like here 2 buys 2 insurances. We can skip one of them, but that is not um, optimization at asymptotic level. It is just like we can maybe, and there can be, each person could have their own insurance, in which case this is messed up. Wait, maybe this works, this works in a amortized way. Okay, for each person, let's, yeah, we could have like for each person, for all the n person, we could have their insurance for the next 10 power 5 generations, which is not very good. This is graph. Shit, I think there is a was a Erecto video about this, about something like this. Let me hide my home screen. Erecto interview. Erecto, Erecto. I think there was a video by him about something like this, something related to this edu. Yes, I think it was this binary lifting. I think it was binary lifting. Keith, ancestor of a tree. No, but I think maybe using something like this, we can find the answer. Like taking inspiration from these things. This is for lowest common ancestor, and this is for kth ancestor of a tree. When we want to find the kth ancestor of a node. No, our problem is we have a graph, a graph. We do not even have a tree. Shit. This is for tree. Yes, this is for a tree. Yes. No, this is not for. Okay, yes, we also have a tree. We also have a tree. We don't have a binary tree, but we do have a tree. Our problem is we have a tree and we need to find out for some specific node. If we go down by some level, let's say 2 levels, how many nodes are there in total in this subtree? Here it is 1, 2, 3, 4, 5, 6. But we should not do this manually. It is not very good to do this manually, we can store sizes of subtrees for each node, sizes of subtrees is starting at each node, and then for all the root nodes, when we are only moving a certain amount of generations down, we can subtract their size from the subtree size of this. But that might also not be very good. And also the question, like, how do we get to all of these nodes at like after a certain amount of generations? How do we get there? Yep, this is, yes, this is something. How do we get there? And we certainly do not want to go through each node by node. We need some optimization. We need some optimization. Yep. No, it is for like, I don't want to show my home screen, my home screen. There might be some things. Yes, I guess the data we get is for tree. Yes, we do have a tree. Keep track of, we have to keep track of duplicates. What do you mean by duplicates? How do you find ancestral node for a parent node? There is a way for finding a bet for quickly finding the kth ancestor of a node. There is a way for finding the kth ancestor. There is a way for finding the kth ancestor, right? But yes, there is a way for finding the kth ancestor, but we want to find the kth children. And I guess even if we were able, we had a formula which we could use for finding the kth child, it might be very slow. Uh, yeah, okay, using this, I do not know how to do this myself, but using binary lifting we can do this. I don't know binary lifting. I have watched the video, but I don't know how to do this. But what I feel is, as it is a E problem, it won't use the difficult concept of binary lifting. Yeah, I don't know about like how the code distribution is in this in at coders. But wait, this is beginner contest. And shit, I took 20 minutes for C problem in a beginner contest. Yes, that is, yeah, that is not very encouraging. Okay, but I guess we have stated the problem pretty clearly, and it is, we have a graph, we have a tree, not a graph, we have a tree, not a random graph. And for any given node, let's say this, we want to find out how many nodes are there in its next, like let's say m generation, y generations. For this one, let's say if y equals 2, there's this and this. If y is 2, 5 nodes in total for the next 2 generations of this node. This. And we need a faster way for calculating this. For calculating this. Okay, the ans we can recursively call this, yes, but that is brute force. Yeah, we do not want to do brute force. For each insurance, there are yep, 10 power 5 insurance. And if we were to say the answer for this node, the like num shit, and also, yes, we don't just need a single number. We actually want to know what those nodes are in all of those generations so that we can add them in a separate set. Yes, because we do not want to. Yes, you were saying something about repeating, right? Yes, we have to keep track of duplicates. Yes, we have to keep track of duplicates. And we don't just need the number. Uh, we need to know what those nodes are in those generations. We will add them in a set, and at the end we will take size of the set. So, well, if that is our goal, then manually going through them seems like the way to go. Like we can say for this node, the answer is all of its for, let's say, some specific node. We can have a function, and it takes an ith node. For ith node, let's say this is the ith node, and this also takes g, let's say g, the number of generations that you want to move forward. So this would be equal to 1 plus answer for this and this. 1 plus f, let's say this is I1, I2, I3, for the ith node, child number 1, child number 2, child number 3. So I1 comma g minus 1 plus f I2 comma g minus 1, and yeah, for all its child. But this just seems slow. Not just slow, but this also seems to be the way to go, because we don't just need a number, we need to know what those nodes are. Yep, we need to know what those nodes are. Let's do this in this straightforward manner without any optimization. Maybe that will work. It's less than 1600. The rating of the problem according to C code forces is at max. Okay, 1600. So we maybe might be able to solve this. That is what I'm saying, to check duplicates. Yep, we need to check for each node, because since we need to know duplicates, then we have to go through nodes. A number will not suffice. We can optimize the usage of set by making the array of size n plus 1 of pool. Yes, we can do that. Instead of using set, we can use a array. But yes, we can do that. That is not the problem. This adding things to the set is not the problem. Problem is just we have to go through each nodes. It seems like we can go up for each node and find if the parent have a insurance, and that 2 greater than or equal to the depth of the child from the parent. So instead of looking at an insurance and finding out all of the people who are covered with that insurance, we can go people by people. We can go people by people and check if that person is being covered in an insurance. Mm, so for each node, we go up, up, up till we reach root. And we will start from each root node. But here, there are like two ways we can begin at each root node, and while going up, we will add this also into the nodes for which we are looking if this is covered in an insurance or not. Or we can go node by node. We can go node by node. Okay, this node, if we just zoom down on this physically, if we zoom down, this node is covered in an insurance if its parent is covered in an insurance with one more generation to spare. Okay, with one more generation to spare. And yes, so we need to know two things: whether this parent is covered in insurance or not, and the maximum number of generations after which its children are also covered in an insurance. Maybe we can, no, for each, if we are going in a BFS manner in the tree, if we are going in a BFS manner in a tree, then at any particular node, it might have a insurance of its own, or let's say we begin with the root node having its own insurance, like the maximum number of insurance generation. So when we add things to the queue in BFS, we will add the node. We will wait, is it dscra? No, we will add the node, the index of the node, let's say 1, and the maximum number of generations for which this goes on forward. So let's say 2. Then we will look at all of its children. We look at this child, and this child might have a insurance of its own, or might not. So we will add this child also into the queue, and we will take its index, let's say its index is 2, comma, maximum of the insurance of the parent minus 1, pi minus 1, comma, insurance of this child if there is one. So child insurance. And I think we can just keep repeating this. Right? But if we go in insurance, like if we get a tree like this, okay, linear, and yes, will be quadratic. Okay, I have like listed a few approaches here, but yeah. This one going from child to parent, I think. If hello, wait, okay, there is a order. Uh, if covered person has an insurance, then we will miss the ancestor. We will miss the ancestor. A person, we will miss the ancestor. I don't get, bro. Okay. If someone we can make all the notes. If we get an insurance, then we can make it. Okay. Intersecting, we use a set, or like you said, you will use a Boolean array. Like if we go from this to one, if we have an intersection, we will use a Boolean array, and if, yeah, we will only count at the end the nodes which have one, which have like true value, content factor, dot dot. Max step, maybe there are intersecting. Max one matters for, okay, like I do not understand what is being said here. I think I have a solution using BFS, and instead of just storing the index of the node, we will store the index plus the maximum generation. Then that insurance is going forward from that point on. Okay, I think I have a solution. I think I don't know. Okay, N and M, and then the tree, we need the tree to be in adjacency list manner. Vector adj, how many elements comes later. uh, wait, no, how many elements comes first, and there are going to be n plus 1 trees, and vector int one I smaller than n I plus plus, smaller than equal to, and we can add 2. C in P, this P, and parent of I is P, so we will say adj P dot pushback I. I is a child of P. I is a child of P, and then for int I equal 0, I is smaller than I plus plus. We'll also have a second vector of integers, then size would be n, and initially everything is 0, and 7 int x comma y, c in x, and y. X is the person who brought the instruction, and insurance, and y is for how much, gen x equals, and n plus 1, maximum of gen x comma y, the maximum generation, and also visited, or covered vector bool size n plus 1 false. And now let's have a queue of pairs of integers, q and q dot insert, q dot push 1, q dot push, yes, 1, comma, gen 1, while q dot, while not q dot empty. Why shit. Uh, we should keep track of both inherited and bide. We do not have to. I think we can just mm, take the maximum. Take the maximum. Yes, we can take the maximum of them and treat them similarly. Sure, but if we go from node to parent till root and we check for the highest parent which satisfied, like are you saying move from child to parent? In what I'm writing here, we are going from parent to child. Okay, let me like check my theory and we'll see if this works. Gen here we are at a generation and auto reference does not matter, x comma y I comma g equals q dot front and q dot pop from the front. Okay, and this we know that we are currently at ith generation. We are currently at the ith node. Okay, and if g greater than 0, then we will say that this person is covered, equals true. Okay, else not, right? And now for all of the children, for int x in all the children of I, q dot, since this is a tree we can just push, there are not going to be any cycles because that logically does not make sense. Q dot push x comma maximum gen x comma g minus 1, maximum of x and g minus 1, right. Okay, and here at the end answer would be, I think there is a function we can use to count all of the true values in covered. Count, yes, count in covered down, begin and covered down, end count, cout, rest. Hopefully this works, or maybe not. Okay, it works here, but it does not work here. Why does it say 3? Let's see. What? Who were the people who were covered in the insurance? And I equals 1. I no yes. I equals 1. I smaller than equal to n I plus plus if, or we can just say see out person number 1, person number 2, person number 3 was not covered. Person number 1, 2 and 3 was not covered. 3 should be covered because of this insurance, but 3 was not covered. 3 was not covered. Wait, 3 should be directly covered. Yes, 3 should be directly covered here. Q, G, X, G minus 1, Gen X. Out. Gen yes, 2 and 3 makes sense, but covered does not make sense. See out I space G. Okay, for 1 we said 2 and we never got to 3. Shit, we never got to 3. 3's parent is 2. 2 was added here. Okay, maybe our graph is not correct. If this is 0, 1 has 2 children, 2 and 4, 3, child number 2 has 1 child, which is child number 3, which is child number 3, which is child number 3, and then child number 3, person number 3 is parent of 3 people, 3 person, 5, 6 and 7. This is making sense, I guess. Is this different or related to this? I think here we are at the right track, just some subtleties. Our tree is also right. Recording. Why are we not adding? We are adding 3, but 3 is being added with 0 here, and 4 is being added with 3. 4 being added with 3 makes sense. Yes, 4 and 3. 1 being added with 2 also makes sense. And then 2 being added with 1 makes sense. Shit, okay. Equal to 0 and as updating generation less than equal to. I think now we are good. Here we are good, and okay, okay, we are getting at least correct answer here. Let's see. This should work. This should work. Yeah. Let's see. Let's see. Let's see how it goes. Increment y. Oh, wait. Waiting for judging. I thought wrong answer or something. Is this like correct or? There we go. There we go. Okay, this is taking quite a bit of memory, but okay, we are happy now. Shit, 3 hour 24 minutes. I had to go with my friend somewhere. He wants to buy a harmonica. Right, cool. We did this. Okay, 45 minutes. 47 minutes. Leave. Yes. Okay, and now as to explaining. Yes, explain like what happened. Harmonica, like the thing which you play like that. Harmonica instrument. This thing. He wants to play Freebird with this. Freebird by Linear Skinnered. He wants to play Freebird on this. It will take some years for him to get there. But okay. So we did this, and it like I think I was not very clear in explaining what happened in this code, but this is the whole thing. Let's take some example. This one. And okay, not example. Let's first look at what the variables are. We are storing the whole graph as an adjacency list, and we have a separate vector called generations, and gen I gives like maximum insurance that goes to next generations. Gen I is the max number of next generations covered. So for example, if gen for I, for some I is 3, that means for that ith person, their next 3 generations have been covered. And initially we have put gen I for all of them equal to -1, which means the person at that point itself is not covered, and none of the generations forward are also not covered. Right? The current person, I person, is also not covered, and the next generations are also not covered. But if gen I equals 0, that means none of the next generation is covered, and that person is covered. Next generations are not covered, but that person is covered. And then here we fill our adjacency list, and here we are filling our generation list. Then we have a vector of covered, where if covered I is true, that means that ith ith person has been covered. And then we have our queue, and in our queue dot front, some like something from our queue, this any element from our queue, this says this will give us a pair, let's say, and let's say the first element of that pair is x and the second element of that pair is y, and then x would be the person and y would be its gen x value currently. Either the x person has directly brought bought an insurance, or they have inherited an insurance from their parent. So here, after looking at the current person that we are at, we look at yes, this is there something covered? Is this current person being covered? That current person is being covered if their g, this gen x value is either 0 or greater than 0. If it is, then we say that the current person, ith person, is covered. And then we look at their children, and for their children we pass, if x is the child of I, then we say, then we are putting x in the queue, and the second value is their maximum generation, and they could have bought an insurance themselves, or they can inherit their parents insurance, and we are taking the maximum of those two values. And yep, at the end we are counting how many people were covered, count covered begin to end, how many values are true in this, and just return the response. I think that makes sense. You're keeping track of maximum number of generations from the current node. We can go. Yes, that tracks both the inheritance. Yes, yes. I have made no difference between an insurance that is inherited or an insurance that has been bought by the person directly. And there should be no difference between these two things. So yeah. And shit, and like reading this question for the first time, it felt like maybe shit, I don't know what complex algorithm is being used here, but no, you're just BFS with some few extra things. But this one is complex, like shit, from yesterday's contest. And yep, that would also be the end of today's stream. It is quite like my approach, but in correct direction. Yes, from parent to child instead of child to parent. And also, I think if you want to go, yes, we can keep each. If you want to go from child to parent, we can just go from child to parent. But yeah, and the problem with your approach would be that insurances are being covered from, are inherited from top to bottom, not from bottom to top. So for current person, we do not know. Yes, from child to parent. But maybe child to parent would also work if we use some kind of recursion, right? Here, we are not using recursion. We are going from from bottom to top, like from parent to child. But yeah, using recursion, maybe this would also work from going child to parent. Insurances are given, if they are given with respect to parent, but maybe we can call a function for a child's parent, looking at what is the maximum insurance that they have for the next generation, either inherited or their own, right? Something like that, that might also work. But yeah, that would be the end of today's stream. We did two questions, in just two questions, and discussed questions from yesterday's contest, and that is it. Thank you for being here. Bye.